All right, guys, so starting chapter 4, okay, random variables, averages, statistics, kind of a variety of things. We're only doing the first 3 sections in chapter 4. The first one's kind of different from the second 2. So this first one's still kind of doing some, more probability, just some different types. So section 4.1 is called on what's called Bernoulli Trials. So a few things with these. Basically, it's an experiment with 2 possible outcomes. So it's like a success or failure. Okay, so we want to think about anything that is either success or not a success. All right. So like rolling a die would not be unless all you're interested in is rolling like a 2. So then it's like a 2 or not a 2. Okay. Bernoulli process is just a sequence of repetitions of that individual trial. Okay. And then one key thing is repetitions are independent. All right. The probability of success is the same on each trial. If it is not the same on each trial, not a Bernoulli trial or not a Bernoulli process. Okay, some examples: flipping a coin, so heads or tails; rolling a die, and again, only if you're interested in just like one outcome or 2 outcomes. So like if it's a 3 or not a 3, something like that. Okay. Multiple choice test, true false test, the right or the wrong. Those are all Bernoulli trials. Okay, so I've got an example here. There's a lot going on this page. So we've got this example, which I'm going to do on the next slide. And then kind of basically there's a formula that we'll use for this. So our example, we have 5 red balls, 3 green balls. We'll draw 3, one after another. The biggest and most important part is this is with replacement. I mean, we're putting it back, meaning the probability doesn't change each time. That allows us to use the formula that we're going to use. Okay, if it's without replacement, we've got to make a tree. All right. This just kind of simplifies it where we don't have to use a tree. All right, just because a tree, some of these trees would be really, really large and hard to deal with. So, some things in this formula. We're going to say R is our number of successes. Okay, N is our number of trials. Say P is our probability of success. Q is our probability of failure. Okay. So this formula that you're going to use, and this is something that you're going to need to memorize and learn. So if I want a probability of R successes, so if we go back to our situation, we want a probability of drawing 2 green balls, so that would be 2 successes in how many trials? 3 trials. All right, and it's just the combination N choosing R times probability of success to the R times probability of failure the N minus R. That's basically R is our number of successes, N minus R, that's our number of failures. If that's easier to think about. So it's P to the number of successes, Q to the number of failures. Okay, so I've got all that stuff labeled there. So on the next slide, I'm going to go ahead and set the formula up and do it. We have a little bit more room. So again, this only works if our probabilities stay the same. Otherwise, we've got to draw out a big tree. So, same with that situation. So, we had 3 trials, right? So, we're drawing 3 balls out. We want a probability of 2 greens, so 2 successes. And then times probability of success. Okay, well, probability of success here, we have 3 green balls out of 8 total. So, probability, and we're saying green is success. So, probability of success would be 3 out of 8. So a 3 out of 8 chance of drawing a green ball. Okay, and we wanted 2 successes. Okay, so we wanted probability of drawing 2 green balls times probability of failure. So that's failure in this case is a red ball. So that's a 5 out of 8 chance. Okay, there are 5 red balls, 3 green balls. And then since we have 3 in our trials, number of trials, okay, we said 2 successes, that means 1 failure. Okay. So just matching all this up. Okay. R. So you can see how everything matches up there. Okay, the 2 is my R, the 1 is my N minus R, P is the 3/8, Q is the 5/8. Okay, and then I just calculate it. And some of these will be easier than others. On the IU tests, generally, if it's some crazy calculations, they'll leave it in the formula, in the form of the formula. This one's not too bad. 3 choose 2 is just 3, and then they have 3/8 squared, so that's going to be, we square both of them, that's 9 over 64 times 5/8 to the first, so 5/8. Okay, that was not too bad to multiply out. I'm going to let you guys do that if you want to, but that's our answer. That would be our probability of drawing 2 green balls. Okay, you could do a tree. Just the tree ends up taking a lot more time. This just kind of saves you some time. Okay, another example. So now we've got NFL kicker makes 1/4 of his field goal attempts from more than 50 yards. Each field goal is independent. Again, this is key. It lets us use our formula. A certain game, he attempts 5 field goals of more than 50 yards. So that's my N. Probability that he will make at least 2 of the 5. Okay, so that's basically 2, 3, 4, or 5 successes. Okay, so meaning we would have to do the formula for each one of these. Obviously, that would take a while, right? You'd have 4 different things you'd have to work out. It's a little easier if we think about when we had things that were at least, if I do 1 minus the probability of what we don't want, so that means 1 success minus the probability of no successes. Okay, if I do that, what's left is 2, 3, 4, 5, right? Because you can either make none, you can make 1, 2, 3, 4, 5. Take out 1 and 0, that's what I'm left with, is what I want. That means 2. Okay? So 1 success, let's just label what we have. So N is 5, R is, in this case for 1 success, would be 1. P, probability of making it, is given here, 1/4. Q is also probability of missing. What's left? 3/4. Either make it or you miss it. Okay. Again, the formula is right up here. All right. So let's just go ahead and do that. So combination N choose R. So that's 5 choose 1 for 1 success. P is 1/4. Okay. R, the exponent, number of successes. So in this case, it was 1 success. Then Q is probability of failure, 3/4. Exponent on Q is number of failures. So if you made 1 field goal, that means you missed 4 because you're attempting 5 field goals. So there's the first one. And then you can subtract out 0 successes. So 5 choosing 0, so R would be 0 now. And then everything else, you've got 1/4 for P. Number of successes, 0. 3/4 number of successes would be 5. Okay, and then we just have to work out the formula. So 5 choose 1 is 5. All right, 1/4. 1/4 to the 1. 3/4 to the 4. All right, obviously some of these are going to be a little bit larger. I'm just going to write it out like this. Okay, 5 choose 0. Anything choose 0 number is 1. 1/4 to 0 is also 1. And then you'd have 3/4 to the 5th power. Okay, this one actually wouldn't be terrible to figure out. You just got to do 4 to the 4th, but then multiply it by 5. This will have the same denominator as that, so you already have a common denominator. That'll happen most of the time on these. Okay. Okay, last example. So we're going to use the Houston Astros here that say they have a 2/3 chance of winning any one game of the World Series. Okay. So obviously didn't happen this year, but as soon as it's always 2/3, no matter the circumstances. In other words, they're independent of each other. The probability doesn't change, and no sign stealing is involved. So that might change the probability. Those of you that follow baseball. World Series best of 7 game series. So the first team to win 4 games is the winner. Okay. So I want to know what's the probability they win in 5 games, meaning they win 4 out of 5. So we're gonna go ahead and just to simplify this. Obviously, if they won their first 4 games, they'd be done, and then they wouldn't play a 5th game. But we'll just kind of forget about that. So we're just gonna say we want 4 successes in 5 trials. So 5 games, 4 successes. Probability of winning 2/3. 4 games that they would be winning. Probability of losing is 1/3. And they lost 1. And we just work that out. Okay. The 5 2 4 is 5. 2 to the 4th would be 8. 2 to the 4th, that equals 1. And this one's not awful, but obviously you can finish that. Main part is getting the formula, getting it simplified. All right, if you want to know win in 6, so now I have 6 games, 4 wins. Okay, so that's 2/3 to the 4th, but now it's 1/3 squared. And then I would work that out. All right, 7 games, very similar. Okay, big key on these, oops, this should be the 3rd power, is make sure your exponents always add your number of trials. If they don't, then you've got something off. Okay, last one, probably that the Nationals win. So obviously you can tell that I made this last year. It might have been last year. Anyway, so probably the Nationals win. So now all this is going to be, and this is in 7 games. So 7. So now I'm going to say success is the Nationals winning. So 4 successes for the Nationals. So what changes here is my probability of success. Since the Nationals would only have a 1/3 chance of winning, since the Astros were 2/3, that makes this 1/3 to the 4th. Probability of the Nationals losing was 2/3. That'd be to the 3rd. Okay. And there it is. So that is the end of this section. Next section will be on probability density functions, which sounds harder than it is. We'll get to eventually.